All right, so we just talked about shifting left, right, up, and down. And I gave you a little preview of how it worked with quadratics, so like absolute value. Okay. Now we're going to look at reflecting quadratics, parabolas, right? So if it's quadratic, the highest exponent on any variable is 2, right? So let's take a look at what reflecting looks like here. So in exercise 1, we have this parabola. It's f of x equals x squared minus 6x plus 5. And off the right, they have a graph of that. Now, you graph those in algebra, I know, okay? A lot of times you just put it in your calculator, table of values, right? And you always have this middle value and everything symmetrical on each side of it, okay? Now we want to think about the graph of g of x when it's negative f of x. So whatever f of x is, okay? Whatever f of x is, yeah, why does it do that all the time? Whatever f of x is, it's negative, right, of all of that stuff. So it's like putting a, minus parentheses times that whole thing, okay? So they want us to determine a formula for g of x. So g of x is negative f of x. So g of x would be negative parentheses, right? What's f of x? This x squared minus 6x plus 5. Okay? Now let's go ahead and distribute through that negative. Of course, you know it's a negative 1 outside the parentheses, right? So g of x will equal negative x squared, right? And then what? Plus 6x minus 5, right? So you effectively just change the sign of everything when you multiply through by a negative, okay? Now they want us to graph that on the grid. Well, maybe we'll throw that into our calculator and get a little table of values. All right? So let's go back to our handy-dandy graphing calculators, or whichever one you use. And I'm going to go out and get rid of all those other functions. Okay, just hit there. All right, now I'm going to add this function. So now we're going to do negative x squared, so negative x squared, right? Plus 6x, we figured, plus 6x, and then minus 5, right? Okay? So let's go and graph that. See what happens. Yeah. Let's put our original in there, by the way. Let's do this. Hang on. Let me kind of look at it. Let me clear that out. I want to put the original one. The original one was x squared minus 6x plus 5. Minus 6x plus 5. Oops. So that's the graph they have in the page here, right? All right, now let's go back and put the negative f of x in there. And that was our negative x squared plus 6x minus 5. Huh, okay. So what does that appear to have done to our graph?
It has formed it. It's completely taken upside down.
It's not rotated,
Reflected.
it's reflected, right? And what would you say is the line of reflection?
The line of reflection is zero axis.
The x-axis, right?
Yeah, x-axis.
Well, let's plot that. Let's get a table of values and plot some, right? So what's our middle x value? Looks like 1, 2, 3, right? An x of 3, and it's kind of symmetrical around that, right? So let's go up and do a little table of values for let's make sure we're on f of x. So let's switch over to, there we go, g of x. Okay? So let's go up to table. Okay. So our middle value is x of like 3, right? That should work out pretty good. All right, so here's some points we can plot. 0, 5, 1, 0, 2, -3. See how if this is our vertex, right? Right, symmetrical around that. So let's go ahead and plot those points. Get our reflection. So, so 1, 2, 3, 4, 1, 2. So there was a point. So you know what I'm doing? Instead of actually using a table of values, I'm kind of, when you do a reflection, every single point is just the same distance to the other side of the line, isn't it? So I'm going to take this point. It's 1, 2, 3 away. So 1, 2, 3, right? Another point like that. And then these will stay there, right? And then this guy up here is 1, 2, 3, 4, 5 from the axis. So 1, 2, 3, 4, 5 on the other side. And the other one comes down level with it, right? So this should be okay. So that will be our g of x. Does anybody have any questions so far? So when we did f of negative x, we ended up with what? We're on part B. We ended up with a what?
Reflection
In what axis?
of the in the x-axis.
X-axis. That's our line of reflection. Okay. And if you remember, when you do a reflection, wherever any point is, whatever distance it is from the line of reflection, it's the same distance to the other side. Okay. So they're pretty easy to graph. Okay. All right. So that was negative f of x. Now in part C, we're going to take a look at a function that's f of negative x. So notice now the multiplying is going to happen inside the function. Okay? So the negative is going to go inside some parentheses here instead of being outside, right, and getting distributed through. So let's see how this will look. So wherever we have an x, we've got to make it negative. Okay? So h of x, right, is going to equal, watch how I do this, negative x squared, right, minus 6 times negative x, and then there's no x in it, so just plus 5, right? So let's simplify this. This first term, negative x squared, what does that become when we square that negative?
Just x.
Well, squared, right? Positive x squared.
Yeah, positive x.
Right? Whenever I square something, I'm going to have a positive value. So negative x squared in parentheses is just going to become x squared. And now the next term is negative 6 times negative x, which gives us what?
Positive 6x.
Plus 6x and then just plus 5. Okay? What do you think this will do? Will this also be a reflection?
Yes.
Mm-hmm. So we made
And
all
it'll be on the y-axis.
right. So we made all the x's the opposite, the negative of what they would be, right? And wouldn't that making all the x's the negative of what they were originally bring them over to the other side of the y-axis over here? Don't make that squiggly in yours, right? Okay. Well, let's put it in our calculator. Let me go table of values and see what happens here. So I'm going to go here. All right, so now we're going to escape out of there. Go over to functions. All right, so let's put that new one in there now. So our h of x here is x squared plus 6x plus 5. All right. So let's see what that looks like. And here it is over here. Everybody see that? So now it looks like when we put the negative inside with the x, right, we reflected it in the y-axis, right? So let me pick a point here. So do you see this original value of x of 3 right here? Do you see my mouse? So x was positive 3 here, right? And we put the negative inside the parentheses with the x, and now what is that x?
Now the x is on.
It's negative 3. It was
Now it's
positive 3. Now it's negative 3, right? So to go from an x of positive to x of negative, you got to flip it over the y-axis, to the other side of the y-axis, right? So when you change the sign of your x, you're going to the other side of the y-axis. Does that make sense? So let's take a look at we could do a table of values, but we're agreeing that it's a reflection, right? So to plot this, we just take each of these points, and this, this is 3 to this side of the y-axis, so we're going to go 3 to that side and do the same for each one, okay? Instead of messing with a table of values. So let's plot that one. We'll do a different color to be clear. All right, back up here. So let's take this first vertex point here. It's how far from the x, that should be red. This is how far from the y-axis. That was a 3. And then so 3 to the other side, right? And we keep doing the same with each one. This one's 2, so 2 over here. And then the other one's 4, so 4 to this side. Kind of getting the idea. This one up here is only 1, so 1 to that side. And that's 1, 2, 3, 4, 5. So this one's 1, 2, 4, 5 to that side of the line. Now this one will stay there, right? Because it's right on the reflection line. And the other one's 1, 2, 3, 4, 5, 6. So 1, 3, 4, 5, 6. So here is our graph of this guy. Okay, so that is our h of x. Anybody have any questions so far? Right? Remember, this is your chance to stop me if you need to clear something up, okay? So what do you think we figured out here, right? So if we're going to multiply by -1, and the negative is outside the function like that, it becomes a reflection, but in what axis?
Will function on the x-axis.
Yeah, because I'm changing all the y values, right?
Inside of the x.
So wait, hang on. If I'm multiplying all the y values in that case by a negative number, it's going to the other side of the x-axis, right? And now the other one, if I multiply by the negative inside, I'm changing all the x values, so it becomes a reflection in what?
The y-axis.
Okay, so we've just worked this out. So here's their summation, right? The function negative f of x, right? If you make all the y values negative, you're going to reflect in the x-axis, right? But if I multiply by negative inside the function, like within the x parameters itself, I'm changing all the x values negative, so it becomes a reflection in the y-axis, right? So you'll need to remember that. These will be, if you can remember that, then most of this problem set's going to be really easy. You probably won't even need a table of values or anything, right? Because you know how to reflect. If it's a reflection of the x-axis, take every point and go the same distance to the other side, okay? Let's look at the exercise 2. Determine an equation for the linear function, right? Because that's x to the first, both after a reflection in the x-axis and in the y-axis. So really, for this one, aren't we going to need the following? We're going to need negative g of x, and what else?
G of negative.
G of negative x, right? So effectively, we're going to need negative g of negative x. So that looks like it's going to be 2 reflections, right? One on the x-axis, one on the y-axis. So let's just plug it in here. So negative g of negative x going to equal the following. So that negative out in front of the g, it's going to make the entire thing negative, where we do parentheses around this guy, okay? And now let's do the negative x portion of it. So that'll be 5 times negative x, right? And then anything happen to the 7, there's no x term on it, right? Like that. So let's simplify this. So negative g of negative x, let's handle this negative here in a bit, would be what? What's 5 times negative x? Negative 5x minus 7, right? Now let's distribute through that negative on the outside. So negative g of negative x will equal what? Distribute the negative through.
5x plus 7.
5x plus 7. And that would be that double reflection, okay? We just handled them both at the same time. Did I lose anybody with that one? We just did both things at one time. All right? All right, let's go to the next page, look at some examples here. Exercise 3. So if a parabola, you know, it's x squared, has this equation, 2x squared, this thing out of the way, okay, minus 3x plus 8, which of the following represents its equation after a reflection in the x-axis, right? So in the x-axis, that means we did negative of the whole f of x, right? If you go back to that table summary, the page before. So let's do that. So negative f of x would be negative the whole thing, right? 2x squared minus 3x plus 8. And so what does that give us as a function when we get done? What will be the
It will
result?
give us negative 2x squared plus 3x minus 8.
Minus 8. Okay, get the idea? And that's choice what? Choice 2. Okay. Now the next one is a reflection in what axis?
The y-axis.
The y-axis. So we're going to do g of what?
G of negative x.
Okay. I want you guys to take a second and go through that. Plug in, you know, every x with a negative in parentheses and then simplify it. Let's see what you come up with. All right. I'll give you a moment. Yeah.
I got number 1.
Number 1. You sure about that?
I'll do it.
Anybody get something different than 1?
2. 2.
I don't know about 2.
Wait, what
happens when you
positive?
Yeah, what happens when you square a negative? You get what?
Also, I think that you got it wrong because you both have 3 and 4 have both still have a square.
No, so it's probably
Well, the square, they're not going to lose the squaring. The squaring will still be there.
Oh,
4.
No, we better go through this one. So that would be 4 times negative x squared, right? Minus 7 times negative x plus 2. So g of negative x will equal, okay, this negative x squared, if you square it, it's just going to be positive x squared, right? Anytime you square something, it ends up being positive. 4x squared, right? Then what?
that'd be positive 7
Plus
plus
7x
7x
plus
plus
2.
So it'd be 3.
Choice 3. You guys see where you got a little sideways there, maybe? Okay. All right. So you got to tighten up with that a little bit, I think. So let's go to exercise 5. Now we have function g of x equals negative x squared plus 4. Now they're going to ask what two transformations have occurred to the graph of just y equals x squared. So we took y equals x squared and we did this stuff to it, right? So we're kind of combining two lessons now. So specify the transformations in the order in which they occurred. Note that there's just more than one. So there's probably more than one way to do this, right? So let's think about this. Negative x squared, right? So we started with this and ended up with a negative x squared. So what did that do to the function? Negative being on the outside of the squaring.
It would be negative,
Well, we know it's a reflection
it's a reflection of the x-axis.
in, right? Because it's outside the parentheses. So it's a reflection in the x-axis.
And it would be what,
And then the plus 4 at the end did what?
up 4.
So it got
up 4.
shifted up 4 afterwards. Okay, get the idea there?
Mr. Henry,
Yes, sir.
for question 4, the one before this one, how do we get +2?
It's right here.
Yeah, but I thought that +2 times negative x would make it -2.
Is there any x with that too?
No.
No, right? So look,
Oh,
it's g of negative x. So wherever there is an x,
I see.
or wherever there's not an x, it doesn't change anything, right?
Yeah, okay.
Now, back in exercise 3, negative f, it's negative the whole thing, right? So then it would change that at the end.
I see.
So that's not a bad question. When you put the negative multiplication inside the function, it's only going to be on any term that has an x on it. Where in exercise 3, it's the entire function, all the y values, right? Get multiplied. So everything in the equation gets multiplied. All right, let's go down to exercise 6. So the graph of f of x shown below. Looks like it's a quadratic of some kind with an x squared. We want us to sketch the graph of negative f of x on A and the graph of f of negative x on B. Okay? Now the graph of we don't even need to know the equation now, right? Now this graph of negative f of x is going to be a reflection in what?
Reflection of the x-axis.
It's going to be a reflection in the x-axis, okay? So this will be a reflection, lowercase r, x-axis, right, for this guy. And the f of negative x will be a reflection in what axis?
The y-axis.
Y-axis. And to do a reflection, you just take every point that's on there and move it over the same distance to the other side of whatever line. Okay? So in this first graph here, A, right, you're going to do, this is going to be negative f of x. And the other one here over B is going to be f of negative x. So I want to give you guys a minute or two to work on that, right? Know what the line of reflection is and just count the same distance to the other side. Plot your points and draw a nice smooth curve through them. All right, so everyone take a minute and do that. You guys can share your screens, right?
Yeah.
So maybe when we get done, I'll have somebody share their screen. Somebody brave enough. Okay? So take a second and plot those reflections. Okay, so the first one is going to be a reflection of the y-axis. Looks like you all got the idea. So I'm going to take the vertex point. It's 1, 2, 3, 4, 5, 6. So 1, 2, 3, not 6. How about a reflection in the y? Yeah, no. What did I just say? We're doing negative f of x, right? Which is a reflection in the x. I just misspoke. So 6 here, and then 1, 2, 3, 4, 5, 6. God bless America. 1, 2, 3, 4, 5, 6, right? Okay, and then the other ones are off of that. And then you can kind of see the relation next to the other points. You don't always have to do the counting. 1, 2, 1, 2, there and there. And these guys just go to the other side. 1, 2, 3, 3, there, and there, right? So it should be, whoops, I got a point. Jeez. Got a point wrong there. This one comes over here. Now it's better. Okay. And the other one's a reflection of the y-axis. So start at the top, 1, 2, 1, 2, right? And that's 1. That's over a couple, right? That one stays, and then 1, 2, 3, 4, 1, 2, 3, 4. And then this one comes to the other side, right? And the other one is 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, like this. And I'm a little sloppy, but, you know, okay? So that's it. So then we've talked about shifting left and right. There's one little trick, like if we go back to 7-1, the trick to the left and right is it's the opposite of the sign, right? And then with reflecting, you're multiplying by -1, you just have to know which one reflects in the x-axis, which one reflects in the y-axis. So does anybody have any questions on any of this? All right, let me give you what your problem set will be all of them except we're going to skip number 9. Okay, so your problem set will be just all of them but skip number 9. Okay. Does anyone have any questions on either 7-1 or 7-2 before we adjourn?
When we do the graphs on our homework, it doesn't matter if it's sloppy or not, right? Like,
I think
do you want us to use like a straight edge or something?
You just make it reasonable, Jacob.
Uh,
Reasonable.
okay.
And some people can draw a nice straight, clear line. It's just got to be clear, like, you know, that you did it correctly. If you don't think you can draw it straight, then just use a straight edge real quick. If you're pretty decent drawing a straight line, but you can't do that with a Prattle, right? But okay. Anybody else? Okay, we'll get back together at what, 9:45. Sound good? Both these assignments, right? So it'll be written down which ones we're skipping. Okay. So we'll see you all at